Good afternoon, everybody. Today, we're going to talk about problem 1 of day 2 of IOI 2021 competition, DNA. The problem is like this. You basically have two sets of DNAs. You can consider this as couples of strings, right? In this case, we only use 3 characters, A, T, C. We don't use G. So the question is, how you can, if you give you 2 strings, 2 DNAs, what is number of mutations it will take to convert from the original string to the target string? That is basically the question. If we look at example that was given here, right? If you want to look at this, okay, so if, for example, if you want to look at, if you have A, T, A, C, A, T, and you want to convert this portion, right, from 1 to 3 to A, C, T, A, T, A. Okay, so if we want to convert from here to here, what are you going to do? So you need to get C to here, right? So the first thing to do is convert to this, right? Swap those 2. The second step is swap those 2, right? So it becomes C, T, A. Right? So 1 step, 2 step. The question is, what is the number of steps if you give you the minimum, if you give you a set, right? And obviously you want to be able to do that in an O(n) complexity. This is actually pretty straightforward. If you think about a set of strings, let's say from here to here, if you can think about a transformation matrix like this. Okay. So let's say this side is your source. Okay. Source, you could have A, and you have T, and you have C, right? And then your target, right? You have A, T, and C. Right? So you have, if you look at this case, you have T to C, right? T to C, that's 1. You have A to T, that's 1. You have C to A, that's 1. Right? So all other places are 0. Okay. So in general, if you have 2, if you think about a case like this, okay, so if you have A something 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 T something something something, let's say this is your source, and if your target also have T something 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 A something 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 something, okay. In other words, you have a A to T, and you have a T to A. You only need 1 swap, right? And then you can get there to. So basically, if you think about, so for example, if you have 3 A to T and you have 2 T to A, okay, if you look at this, that means you have 2 pairs, you can do ATTA swap, right? So that is, then you have to have 2. Okay, so then if you remove that, what's left is 0 and the left is 1. Then you left have 1 case, you have A to T, but you don't have T to A, right? It's like this case. You have A to T, but you don't have T to A. Then in this case, as we said, you need 2 times. So then you need plus 2 times of, let's say, what is residue, right? Okay, so if you have this transformation matrix, then you can easily, for each of those, right, A to T, A to C, T to C, you only have to consider those 3 cases, right? So A to T, A to C, right, and T to C, those 3 cases. Okay, you find the minimum, right? This is, you find the minimum. Therefore, and then you add 2 times of the residue, right, from the transfer matrix. That is basically your question, your answer, right? Now, the only thing left is how to calculate this transfer matrix, right? For a string, right? For a string, from, let's say he wants from X to Y, right? That is actually pretty easy, we know, right? So if we do, that's our standard Poisson stuff, right? So basically dp of, let me show now say dp. If I count, okay, I'll put if dp of I is all the way from start to I, right? Then if I want to count between X to Y, it's obviously of dp of Y minus dp of X minus 1. Okay, so make it easy. I'll count from, they count from 0 to n minus 1. I'll just count from 1 to n. I'll shift it, shift 1. Right? So then you need this transfer matrix, right? You need to have, each of them have 3 cases. So you have to have your dp. Effectively, your dp is going to be like this. dp of I, which is up to from 1 to I, right? If I consider the string from 1 to I, then the first string, right? What would be my first string, first DNA, right? It will be, as I said earlier, it will be A, T, or C, right? So A, T, or C, let's code it as 0, 1, 2, right? So what would be my second string, second DOI? Again, A, T, and C, right? 0, 1, 2, right? So that will be my DP. Right? Then the transition from I minus 1, right? Transition from I minus 1 to I is easy, right? So how many of, basically is how many of those situation happens? So I first add from my dp of I minus 1, right? So for each of my previous case, right? For each combination, 0, 1, 2, 0, 1, 2, all the combinations, right? I add it up. My dp of previous, then my dp of I. In this case, I know exactly at what's the DNA for at I's place, what's the DNA for the second place, right? So basically DNA of first one, and DNA of second one at I, right? So that case, I will increase by 1, right? So because that situation increased by 1. Other situation is not increased, it's the same as before. So that's pretty much about it. The only case is, what if, to make it work, the number within this, right? Number of T's from first one has to be equal to number of T's of first one. Number of A of first one has to be number of A of the second one. Number of C in the first DNA has to equal number of C in the second DNA. That can be a very simple another DP, right? Just count it. It's just pre-sum of it. You can do, you can do DP, let's say DP1 of up to I, DP2 of up to I. I mean, you have to have what is the DNA at that place, right? Or if you make it simple, how about if we just do a delta of that, right? Of whatever that DNA is, right? So then from X to Y, right? From between X to Y, this delta has to be 0, right? For each of the character, each of the A, T, and C. So you do that check to make sure that you have the same number of A and T and C. If that is true, then you do this conversion matrix. Okay. What's the complexity? You first have to calculate all of those. You have to calculate the DP, you have to calculate the delta, but you do it once, right? You do it once, that is all of n, times 9, right? Because it's you have to do that matrix. So basically, it's O of n, right? It's O of n. Then each time you calculate, that is O of 1, right? Then the initiation is O of n. Each time you get is O of 1. So that's actually a very straightforward DP. Can't believe it's so easy. So here is example code. Okay. So when we do initiation, right? So I have my DP. I mean, I count it as a sum, right? So first I make it DP of I equals to DP of I minus 1, right? For each of those first string and second string. Then what is my index of first string at okay? And then what's the of my second string? Okay. Then my sum just plus. Right? So then my delta, increase by the first string and reduce by second string. Then when I try to get, I will just try to see if first I check, right? I have the same number of A, T, and C. So the delta between Y and X has to be 0, right? If that's the case, then I make the conversion matrix, right? From Y minus X, right? Make a conversion matrix. Then I find the minimum from A to T, A to C, T to C, right? I add it up. Then for then the residue, I add up twice. Right? So as I was saying a moment ago, right? Oops. Add up the residue, add up the minimum, right? Find the minimum, add up the minimum, and the residue add up twice because I have to do 2 swap. Then I just return the answer. Right? If I run that, a simple example, and that was my composition matrix, right? And then the residue in this case is 2. Right? So that's basically the answer. I give you a example case here, so that it's easier for you to understand. So you can look at this case, right? Example answer. So you can look at it, and it's pretty straightforward on how to do this. Okay. So so by the way, notice I did and just like this example, I used shift of the index because it's just easier, much easier to deal with x-1. So that's pretty much about it. So that's a DNA question. Today's homework. Take a look at this. So understand it, and then look at the next problem. The next problem number 2. Problem number 2 is dungeons. Okay. Just to give everybody a hint, it is somewhat similar kind of DP. Okay. But it's more complex because unlike this case, you can do ON. In here, the number is much bigger. So you have to use the concept called bit lift. If you don't remember what that is, it's what we do when we do lowest common ancestor, right? Least common ancestor. When you do a tree, you jump up the tree by factor of 2 every time. So if you look at again from Benjamin Qi's UCycle guide, if you go to the platinum level and binary jump, okay, you need to do a DP, but you don't want to do, because it's going to be n squared. You don't want to do n cubed in the end if you just do straight DP like what we're doing at MDA. So you want to convert it from n to log n. So basically use binary jump. Read this. If you cannot remember what binary jump is, read that and come back, try to solve the dungeon problem. Okay. Then next week, we will talk about the solution for the dungeon game. Good luck, and I will see you next week.